to solve this differential equation, we'll start by separating the variables. So we have cos x squared So what I'll start with is by rewriting this part, and that can be written as cos x squared dy over dx is equals to 1 over e to the power 2y. And then what I'm going to do next is to multiply both sides by that denominator, and actually cross multiply this guy so that I can separate the y and the x guys together. So what I'll end up with is e to the power 2y dy is equal to dx over cos. So basically what I've done is to rearrange it to end up with that. And this can be written as e to the power 2y dy is equals to now 1 over cos x squared is same as secant of x squared. All right. And now at this stage, we can go ahead and integrate each side separately. So what we'll end up with is the left side will be e to the power 2y over 2, and that will be equal to the integral of secant of x squared is just an x. All right. And then the question here is asking us to find a particular solution, because we are given this case here. We are given the value of x and y. All right. And we need to write our answer in that form. So anyway, back to where we are. So what we need to do is to use the known point to find c. So which means what you're going to do, we know that at x is equal to pi over 4, y is equals to a half. So I'm going to plug that into this equation. So I'll end up with e. So this guy here basically becomes e to the power 2 in bracket a half over 2. That will be equal to 10 into bracket pi over 4 plus c. And remember, what you're looking for here is the c guy. So that means we'll end up with e over 2 now tan pi over 4 is just 1 plus c, and this implies that c will be equal to e over 2 minus 1. All right. So c is that. So all that we need to do now is to go back and plug c into this equation here. Okay. So what we'll end up with is so you can say therefore e to the power 2y over 2 will be equal to tan x plus e over 2 minus 1. Now, in the question, we'll be asked to write our answer in this form. So what I need to do now is to go back here and try to find a way of making y the subject of the formula. And to do that, what I'm going to do is to take the logarithm of both sides. So ln of e to the power 2y Now, actually, before I take ln, let me multiply both sides by 2. So if I multiply both sides by 2, I'll end up with e to power 2y will be equal to 2 tan x plus e minus 2. Okay, and now what I'm going to do is to take ln of both sides. All right, so this bit can be simplified to just that will be 2y if you simplify that. So we'll end up with 2y is equals to ln 2 tan x plus e minus 2, which means y will be equal to a half of ln 2 tan x plus e minus 2. And that will be our required solution. In this question, we are required to solve this differential equation. So the first thing that we're going to do is to separate the variables. So we have 2x dy over dx minus 1 is equals to y squared. So maybe what I can do is to rearrange it. Maybe I can start by multiplying by dx on both sides. So that will be 2x dy is equal. Now actually I can rearrange this to 2x dy over dx is equal to y squared plus 1. Now, and then I can multiply the right hand side by dx. So move dx on the other side. Okay, and then what we can do is to rearrange it so that we have y's on one side and then x's on the other side. So that will be dy over y squared plus 1 is equal to dx over 2x. And then, well, this can be written as 1 over y squared plus 1 is equal to 1 over 2x. And at this stage, we can just go ahead and integrate each side separately. So what we'll end up with is arc tan y if you check your formula booklet, you should be able to see that. And this will just be a half ln x plus c. So at this stage, we have a general solution. Now, but we are required here in this question to find a particular solution. So we are going to use a known point to find a particular solution. So basically use known point to find C. So we know that at x is equals to 1, y is equals to 1. All right. So we just need to plug that into our equation. So we'll end up with arc tan 1 will be equal to a half ln 1 plus c, and arc tan 1 is just pi over 4. That will be equal to c, which means Now that we have C, we can put these guys together, all right, to find our particular solution. So what we'll end up with is arctan y. So therefore, arctan y will be equal to a half ln x plus pi over 4. Or you can just say that um, y is equals to tan a half ln x plus pi over 4.